And the opportunity to make a whirlwind tour of the world like that is utterly amazing for lots of reasons. You see some incredible stuff, and you get to make these spot comparisons between people all around the globe. And the thing that you really take away from that, the kind of surface thing that you take away from it, is not that we're all one, although I'm going to tell you about that, but rather how different we are. There is so much diversity around the globe. 6,000 different languages, spoken by 6.5 billion people, all different colors, shapes, sizes. You walk down the street in any big city, you travel like that, and you are amazed at the diversity in the human species. How do we explain that diversity? Well, that's what I'm going to talk about today, is how we're using the tools of genetics, population genetics in particular, to tell us how we generated this diversity and how long it took. First one is really a question of origins. Do we all share a common origin, in fact? And given that we do, and that's the assumption everybody I think in this room would make, when was that? When did we originate as a species? How long have we been diverging from each other? And the second question is related but slightly different. If we do spring from a common source, how did we come to occupy every corner of the globe? And in the process, generate all of this diversity, the different ways of life, the different appearances, the different languages around the world. Darwin was talking about our distant ancestry, our common ancestry with apes. And it is quite clear that apes originated on the African continent around 23 million years ago. They appear on the fossil record. But that's not really the question I'm asking. I'm asking about our human ancestry, things that we would recognize as being like us if they were sitting here in the room. Well, what I'm going to talk about today, what I'm going to talk about now, is a new approach to this problem. And what we need to do is turn the problem on its head, because what we're really asking is a genealogical problem, or a genealogical question. What we're trying to do is construct a family tree for everybody alive today. And as any genealogist will tell you, anybody have a member of the family, or maybe you've tried to construct a family tree, trace back in time. You start in the present with relationships you're certain about. You and your sibling share a parent in common. You and your cousin share a grandparent in common. And you gradually trace further and further back into the past, adding these ever more distant relationships. But eventually, no matter how good you are at digging up the church records and all that stuff, you hit what the genealogists call a brick wall, a point beyond which you don't know anything else about your ancestors, and you enter this dark and mysterious realm we call history, that we have to feel our way through with whispered guidance. Who were these people who came before? We have no written record. Well, actually we do. Written in our DNA, in our genetic code. We have a historical document that takes us back in time to the very earliest days of our species. And that's what we study. If you take all the DNA out of every cell in your body and you stretch it end to end, it would reach from here to the moon and back thousands of times. It's a lot of information. And so when you're copying this DNA molecule to pass it on, it's a pretty tough job. Imagine the longest book you can think of, War and Peace, and now multiply it by 100. And imagine copying that by hand. And you're working away until late at night, and you're very, very careful, and you're drinking coffee, and you're paying attention, but occasionally, when you're copying this by hand, you're gonna make a little typo, a spelling mistake. Substitute an I for an E, or a C for a T. Same thing happens to our DNA as it's being passed on through the generations. It doesn't happen very often. We have a proofreading mechanism built in, but when it does happen, and these changes get transmitted down through the generations, they become markers of descent. If you share a marker with someone, it means you share an ancestor at some point in the past, the person who first had that change in their DNA.